Okay, now we continue in English, and I will ask Teemu to take over. So Teemu, welcome.
Thank you. Can you hear me again? Yes, you can.
We can hear you.
Yes, yes, we can.
Yes.
Of course.
Somebody was nodding there, so I was interpreting that it's okay. Yes, I'm Teemu Heikkinen. I come from Finland, Satakunta University of Applied Sciences. Thank you for having me. It's always interesting to be involved in a webinar where you can't understand anything people are saying mostly, but it's nice that we have something in English also here now. So I have a small presentation for you. Try to share it now. Hopefully you can see it now. So the subject was this energy efficiency in small ports. And my presentation will constitute of basics in energy efficiency and then some examples. Is it changing the slide? Yes, this is the content. So some basics, what it means, what energy efficiency means, and then what it means for small ports, what it could be, where energy is consumed and what you can do about it. Then some basics about solar energy utilization, which is one way you can produce your own energy at ports also. And then some of my examples, what we have done in earlier projects. Also in this project, I have one example from Scotland. Okay, then some basics. So what is energy efficiency? It's basically just saving energy. So with some improved energy efficiency, less energy is consumed for the same task as earlier, and some energy is saved. But that's simply what it is. You use either technical ways or process change behavior so that less energy is consumed. So basically, the produced and bought energy is used in an efficient way. Then there's this term which might be useful for you in the future, this specific consumption or nominal consumption also, which is kind of term that is often used when talking about energy efficiency. It's a term that you can use for comparing, let's say, for example, energy consumption of different buildings. So it's energy per certain, for example, area or cubic meter of space. So it's easier to compare different kind of buildings. Energy efficiency means also emission decrease and saving of natural resources. And then some keys, what are keys to improve your energy efficiency is that at first you need to know the current situation. So to measure the current use of energy and especially identify the most wasteful gadgets or processes you have there, so which uses most energy. Then secondly, plan for both technical and functional improvements. What you can change, what you can change, which gadgets you can change, what can you do to make your functions more energy efficient. Then you implement those, and then it's good to always to verify the change, that compare to the first phase, that what's the new situation, has there been energy savings. A simple way to start is really to start thinking about your energy consumption. It's often that people don't even think about, especially if it's so that energy is not that big thing or it's not that costly, it's often kind of neglected. But it's when you start thinking about it, you often notice that what could be the place you could save some energy. And the motivation really, of course, the climate change, it's not good. It's worth fighting for, or let's say fight against, and of course saving some money along the way. Here on the right side, on the green surface, there's some examples of what this means. What is 1 kilowatt hour of energy? Examples. For example, 100 hours lights on with the 10 watt light. There's some example then about the specific consumption or nominal consumption, what it means. There could be some tables available nationally. I don't know about Latvian case, but there could be some tables available from the government or some energy agency that you could use for comparing your nominal consumption with some general consumption readings, so you know which kind of where you are kind of in terms of energy efficiency. Then I put some link. I don't know if the term is familiar to you. These energy saving companies, ESCOs, which is a kind of this goes to EU websites. It's a kind of EU promoted or this kind of initiative that companies that offer energy services, but also not just normal companies, but the idea there is that they also kind of they give you financial aids, or that sense that the investments is totally or partly paid with the savings you get from the energy. So that's the idea there, that so it might be that you don't have to kind of pay anything, but you just give or you kind of how to say, you pay with the savings you get. And something about the small pots. What's the energy consumption in small pots? There's some list first here for where energy goes in small pots. So of course, if you provide electricity for visiting boats, that's one kind of specific for guest boats and visiting boats. Can be big if you have lots of boats there and visiting, and depending on the day, of course, how many there are, etc. Then other thing is if you have a buildings there at the port, and if you have a ventilation there, mechanical ventilation, so there's a machine circulating the air there, that's consuming energy year round if there is one. Space heating, if you have a need for space heating, if you have houses or buildings which need to be heated year round, of course you have some energy expenses there. Then cooling or air conditioning, summertime consumes energy. Lighting, indoors, outdoors, piers would have lighting. Then refrigeration equipment, so if you have freezers or fridges there where you have beverages or something for your clients, for your customers, those consume energy. Sauna, if you have sauna, I don't know how common this is in Latvia, but in Finland this is a big thing that almost every port have a sauna, and it's a quite big consumer of energy. If you have some washing facility, shower, for example, heating of water takes lots of energy. So the less you use energy or use water or etc. So the more you save energy also. Then if you have some kitchen cooking equipment or laundry machines and tumble dryers, etc., of course those also consume energy. So what you can do about this, for examples? So these are like pairs now. Left is where it goes and what you can do. The right side. So you may maybe educate the boaters on how to, or maybe not to use so much energy if it's not necessary, or it can cost more to them, etc. Or then you can have your own solar energy plant to compensate, because it's nice match with the summertime. You get best solar energy, or you get it's good time to produce solar energy, so it's good match with the consumption of boaters. Then with this ventilation, automation is good to install some automation that there's no needless ventilation, but it's based on moisture or carbon dioxide amounts, so that the air is good, but not like needlessly good, or So then as a space heating, you can lower your room temperatures, especially in winter time if there's no people inside. Also their automation, utilizing passive solar energy, so letting the sun in and etc. Better insulation, of course. Cooling, air conditioning for that. You could use sunshades or eaves. Also on PV plant, also in this case, it could be used for producing energy for the heat pumps that are used for cooling. So usually when there's a biggest need for cooling, there's also best sun available. Lighting, change to LED lighting. Automation with the motion or presence detectors. So only when there's people at the area or at the room, then its lighting is needed. And if there's if there's a dark enough, or you can even just partly use the part of the lighting, for example, outdoors. If there's no one, just part of the lights are on, and if there's more people or people coming in the area, then all the lights turns on. Or let's say the 100% of the power is turned on. Then refrigeration equipment, energy efficient equipment is good, especially if you have to renew your equipment. Make sure that the new ones are like good ones in terms of energy efficiency. And also the location should be thinking about where you locate your equipment so that it's not it's good ventilated, so that the fridge doesn't have to make needless work. In sauna, if you have sauna, it's better to have well insulated, because there's a big temperature difference always. Even though it's 30 degrees outside, it's 80 inside, so it's a big difference. So good insulation is important. Then what comes to water heating, avoid overheating of the water. So just 55 is enough. If it's just if there's enough water for the washing, but if it's too hot, it's just wastes like more energy to the surroundings. And you can adjust the water flow so that it's adequate, but not too much pressure there. And you can affect the nozzles and automation. Also, solar thermal solar thermal plant can be installed for heating water. Then what comes to kitchen and laundry, etc. So just invest in energy efficient equipment. And what is always important is to check for your port that the situation, really make some kind of audit, either yourself or using experts, that what is the situation in your port. Then something about the PV power plant basics. So how does it constitute? As you probably all know, there's these solar PV panels, which are the most visible part of the system. They can be installed on roof, wall, or ground. Then they produce district current, so like similar kind of like these batteries used for different gadgets. So it's different than used for normal house appliances. So that's why you need this solar inverter, which main purpose is to change the DC to AC, so it can be used for different gadgets, equipment, devices in your house. And there's usually, at least in Finland, this is required. There's this safety switch that is for the grid operators, that they can switch off your system in case there's some maintenance work ongoing on the network. This is kind of the equipment that you are installing. And then on the right side is your house equipment, existing house equipment. There's a distribution board of the house where you connect the system. And from there, it's distributed to the different appliances in the house. And if there's excess energy, it goes through the meter to the grid. And when you don't have enough from the sun, like which is of course usual during nighttime, etc., you buy the energy from here. Then some more details. Also in Latvia, Latvia is also already a very good place for very good PV potential to produce solar energy. And the best usually in everywhere in the northern hemisphere is to have the facing the panels to south and the inclination of about 40 degrees. And then there are one-phase and three-phase PV systems. So meaning that they are, if you have a, we usually have this three-phase electricity system in place. So it produces one-phase system produces to only one phase this electricity, and three-phase system divides to evenly with all phases. And good to remember that the production and consumption is never in balance. So you need to get the rest of the electricity from the grid, and if you have some excess, you are selling it to the grid. And usually there is a own agreement needed for this latter one, so selling the excess energy. Yes, also batteries can be added to the system, but normally they are without the batteries, this grid connected systems, because batteries are still quite expensive investment. And here at the bottom, there's just a table where you can kind of, it's from Pori location. It tells that how much it affects where the panels are directed, whether they are south, which is the best one, or whether they are somewhere else between west and east. And then there's the inclination of the panels, how they affect. So you can see that in the middle, the green one, it's actually quite a wide area, or the yellow one. So every direction between southeast and southwest are good, and if it's like from let's say 15 to 60 degrees, it's already quite good, the production amounts. And the other system is this self-sufficient PV power plant, meaning off-grid, where you have no grid available, so you don't get any energy from external grid. So you are kind of need to produce all the energy yourself. So then you need this battery. You have panels, which can be about the same as in an on-grid system, usually a bit different. Then you have charge controller, which controls the charging of the batteries, that they are not overloaded or underloaded, too much discharged. Then you have either from the charge controller or batteries, you have delivered the energy to devices and sockets in the house. And you can also extend the system so that there's this AC network option. Then you need this inverter, which is different device than the solar inverter. It's a different purpose, at least partly different purpose. And then you need this one, and then you have a regular power, there. An example, a picture from one island in one small port. There's a small PV panel on the wall, and there's the charge controller and switch box, and there's a battery under these. Very small system. There's also a small inverter, so the energy is converted in this case to AC and delivered to lighting of pathways. Then a couple of points of off-grid system still. So the proper sizing is important, and etc. You can read it there later on. What other you can do with solar energy? Like mentioned already previously, there are these solar thermal solar collectors, which can be used for space heating and domestic hot water heating. So they look a bit like same but in there's a circulating fluid, water, glycol mix, which is heated by the sun, and then it's collected to water tanks and can be used for heating the house or heating the hot water, domestic hot water. It's the basic idea. There's actually a picture also of it. So there's these collectors which look like a panel, and there's a circulating fluid there, going cold water and coming hot water back, and it's stored to this tank. It's also one option. It's kind of, let's say it's the solar electricity system have kind of taken over pretty much the solar thermal, mostly because of the costs. The cost of PV has gone down much faster than the cost of solar collectors. So that's the reason why it's not that popular. Then there are air collectors, which are very simple devices. They can be used for ventilation and moisture removal of room or house. Especially good for houses with no mechanical ventilation. So they change the air and dry the air a bit. This is how they look. The idea is there that the sun heats the collector and it heats up the air, and then the hot air is blown inside. Hot and dry air, or warm and dry air, is blown inside. So it kind of replaces the more moist air from the inside and also heats up a bit. So there's also a small PV panel there to make the fan going. Power the fan. Then not to forget the passive utilization. So when you need heating, don't block the sun with the curtains, but let the heat in and the light in. And also if there's too hot, you could use curtains or rather these eaves or other shadings to block the heating sun. Then something about investments and examples, what have been done. This is the first one is from Finland, Rauma, Kylmäpihlaja Lighthouse Island. There is now 2 PV systems installed. Other ones there's this lighthouse building, older building. On top of that, there's a 12.5 kilowatt peak PV system, which produces about 10,000 kilowatt hours per year. Then there's another one, a new service building, and on top of that there was installed 5.2 kilowatt peaks PV system, and the production for that is about 4.4 megawatt hours per year, or 4,470 kilowatt hours per year. And here you can see kind of how it's divided. This is from this free software by EU you can use for estimating your productions. So in Finland, it is very typical, especially that during the January, November, December, you hardly get anything from the sun, but during the summer, it's very good potential. Then another example from Sweden. These are from this is from a city port of Gävle. There was installed this kind of LED lighting under the rails in the small port, so it illuminates the pier area during dark hours. Nice lighting there. And then there's from Söderhamn archipelago, there's a Styrinjufrun Island, and there is a Fyrhamn port. From there, there's 3 other pictures are. There's a couple of off-grid systems installed there. One of these is here. The batteries are under the box there on the ground, and they are lighting the pier lightings of these, and also the pathway lightings of this kind in the island. There's no power cable coming from the shore in this island, so it's used to be real dark island, but now there's some lighting also for and electricity available. Then another example from Åland, Havspaviljon Tjökar. In there was in the project there was totally new service building made, and with the building there came the heat pump was installed, some LED lighting indoors, and also rather big PV system on the roof of the building. And then this is from the current project. This project that this webinar belongs to also CBSmallPorts. This is investment done in Sweden in Plese Kalk Group, Gotland. There was during winter, as you can see, there's snow. There was installed a rather big PV system, 31.6 kilowatt peaks system on the top of this. There's this Limeworks museum there, and in this building there's this museum and a restaurant, and it's producing estimated about 28,000 kilowatt hours per year. As you can see here, it's it's not the optimal direction because it's this roof here that it was installed on. So it's about to the southeast, a bit more east, even about 60 degrees from south the direction. Here's the location of the place in northern part of Gotland. And here's also a picture of the monitoring system of this system. So you can see this is from this morning, 9:05 this morning. Sorry. Yeah, this is from 5:00 morning, and you can see the sharing how it goes. This is how much was sold, and this is how much you had to get from the grid. Pretty nice view. You could also see the phases, how different phases are producing and consuming, and how much you are selling to the grid. Yes, thank you. That was my presentation. I don't know if there was any room for the questions, but thank you.
Thank you, Teemu. That was interesting presentation. Thank you very much. I will ask if somebody have any question or would like to make a little comments, because we are looking forward for the comments as well, not only questions.
Yes. You can comment also in Latvian. I don't mind, but I don't just understand.
So, anything? Okay, so presumably everything was clear at the moment.